Combining resistors in a compound circuit. The equivalent resistance of resistors connected in series is the sum of their values. The equivalent resistance for a pair of equal resistors in parallel is half of the value of either resistor. Sometimes it's useful to know the equivalent resistance or total equivalent resistance of a circuit that has several resistors in its network. The equivalent resistance is the value of the single resistor that would comprise the same load to the battery or power source. The equivalent resistance of resistors connected in series is just the sum of their values. For example, the equivalent resistance of a pair of 1 ohm resistors in series is simply 2 ohms. Here's how it works. If we have one in series that is in parallel with these two. So looking at this as our circuit, how would we combine all three of these? I talked about how to combine resistors in parallel back when looking at parallel circuits. The equivalent resistance for a pair of equal resistors in parallel is half the value of either resistor. So the equivalent resistance for a pair of 1 ohm resistors in parallel is 0.5 ohms. Let's check that. Alright, so remember I told you to add in parallel the resistance. Oh, that's a terrible color. Resistance in parallel is just the inverse of the first resistor plus the inverse of the second resistor, and then take all of that and inverse it again. Remember what inverse means. It means 1 over R1 plus 1 over R2, and then you're going to take that and you're going to inverse it again. So all of this would be inversed again. Just don't forget that last little step. But before I keep going or get too mathy here, let's take a look. So if we have the inverse of R1, so 1 over 8, plus the inverse of R2, which is 1 over 8, and then we take the inverse of that, 1/8 plus 1/8 is 2/8, and we're taking the inverse of that, which is 8/2, which is 4. You'll see the 4 right here. This 8 ohm here comes from that one right there. So the equivalent resistance for a pair of 1 ohm resistors in parallel would be 0.5 ohms. If we look at this 8 ohms, it's half of the value for either resistor, right? Because these two resistors are the same. So that's kind of a shortcut, knowing that it's half of the value. All right. The equivalent resistance is less because the current has twice the path width when it takes the parallel path. So, whoa. All right. Looking at this again. So we start off with 1 ohm resistor, which is in series with these two that are in parallel with each other. So the first thing you want to do when looking at a compound circuit that has series and parallel in it is to collapse your parallel circuit so that way you can combine your series. Ideally, you want to deal with series because you're just adding them up, right? So if we can collapse these two, combine them together to get one equivalent resistance, then that means we now have 2 resistors that are in series with each other. And if we have 2 that are in series with each other, we know we can just add 8 plus 4 to give us a total equivalent resistance of 12 ohms for the entire circuit. Takes practice. Takes a lot of practice, so make sure you're trying this out. The equivalent resistance of 2 ohm resistors in series is 16 ohms. The equivalent resistance of 2 8 ohm resistors in parallel is half of each individual because they're the same, so it's 4 ohms. For a combination of 3 8 ohm resistors, the 2 resistors in parallel are equivalent to a 4 ohm resistor, as we proved earlier. They're in series with an 8 ohm resistor, adding to produce an equivalent resistance of 12 ohms. If a 12 volt battery were connected to these resistors, the current would then be 1 amp. We know that because we have Ohm's law that we talked about previously. And Ohm's law, we said if the temperature is constant, then V equals I times R. V, we said, is 12, and we said the equivalent resistance is 12, so I times 12, because R is 12 and V is 12. I know that's V, and I know this is R. So what is I? Well, we'll divide 12 from each side, and we get I equals 1 amp. In practice, it would be less, for there is resistance inside the battery as well, called internal resistance. That's a little bit of a separate topic, but basically the current, when it goes through the battery, is going to encounter some resistance. So it's not perfect like we have here. Schematic diagrams for an arrangement of various electric devices. The equivalent resistance in the circuit for this mess is 10 ohms. How did we get to 10 ohms? First, looking at this circuit, first thing I would do is I would collapse these two parallel. And I would say 8 and 8 is going to be 4 here. So every time I combine any resistors, I redraw the circuit. So 8 and 8 becomes 4 plus 16, so that is 20. And then I have 10 and 10 in series with each other. 10 plus 10 is 20. Now I have 20 and 20 in parallel, so I'm going to collapse those. Those two are the same, so I know my total equivalent resistance is going to be half the value of either one of these. Or inverse of 20 plus the inverse of 20, and inversing that answer will give us 10. Now I can go through and I can do V equals I times R to figure out the current for this entire circuit. So I would say 60 equals I times 10, divide each side by 10, and we get a current of 6 amps for this entire circuit. Then I can go backwards and I can say, okay, what stays the same in series and what stays the same in parallel? And then I know that in series, current would stay the same, and in parallel, voltage would stay the same. So 60 volts, 60 volts, 60 volts, because in parallel, potential difference stays the same. And my current would be, I have V and I have I, I have V and I have R, so then I can do V equals IR, V equals IR, and figure out what that is, and then I can go back here. Current stays the same, whatever my current was from this, and just keep going back and forth. Perhaps we should do an example. In the circuit below, what is the current in amps through the pair of 10 ohm resistors? Try it for yourself. See if you get the same thing that I just got in my ramblings. Total resistance of the middle branch is 20 ohms. Since the voltage is 60, the current equals 3 amps. The current through each pair of 8 ohm resistors is 3 amps, and the current through each is therefore 1.5. I'm going to do this one.